To build a weatherproof fiber backbone, convert the Starlink signal from the RV, shoot it through fiber optic cable, and then convert it back to standard network signal at the ranch. Hi tech lovers! Welcome back to Fast Cabling. So we've all got that spot in the backyard where the Wi-Fi drops. But for our client today, that dead zone is their entire 500 meters ranch. So the property owners is using Starlink on this RV. It's fast, it's reliable, right there. But the ranch operation, the gas cabin, the security cameras are way out there. They needed high-speed internet for smart irrigation sensors, security cameras, and gas Wi-Fi. But standard Wi-Fi can go 500 meters, and running regular Ethernet, that's a disaster waiting to happen. It's limited to 100 meters and acts like a lightning rod out in the open. So we're facing a classic ranch versus technology showdown, and we're going to win it with fiber optics. So our solution is to build a weatherproof fiber backbone. We're going to convert the Starlink signal from the RV, shoot it through fiber optic cable, and then convert it back to standard network signal at the ranch. And this gives us distance, protection, and the speeds that will handle whatever the future throws at it. Now the path looks like this. It starts at the Starlink router inside the RV, hits a fiber media converter, and travel across the property on this fiber optic cable, lands at an outdoor PoE switch, and finally powers the camera and the access point. Sounds perfect. Let's build it. So first up, the RV. Here's our Starlink. Now most Starlink kits just give you Wi-Fi. So to get a physical cable out, you need the official Starlink Ethernet adapter. It plugs into the router and gives us a standard RJ45 port. That's our starting line. So let's use a short patch cord, connect to the adapter to where? Here's our first piece of heavy artillery. This is our outdoor fiber media converter. It's the translator. Its job is simple. Take the electrical signal from the Ethernet cable and convert it into parts of light for the fiber. But this is critical. You cannot use the cheap plastic bag from anywhere out there. This one here is rugged industrial rated unit. It's sealed in an IP67 housing, which means it's dustproof and waterproof. It's rated to handle from 40 below zero to 75 degrees Celsius. Consumer gear would fry in the summer heat or just stop working in the winter. And this is the difference between a setup that lasts one season and one that lasts 10 years. And this one is also DIN rail mounted. With this special tool, you can mount it on a DIN rail flexibly. So in order to connect it, I'm going to take out the neck and the gland, but when you do the installation, make sure you use the Ethernet cable to pull it through. Now I'm going to connect our Ethernet cable to the RJ45 port on this side. And on the other side, we have the SFP slots. Now before we do it, we'll need this little thing. This is the SFP module. Think of it as an engine that creates the light signal. But look closely. There's only one port. This is called a BiDi bidirectional module. Here's the science magic. Standard fiber used to require two strings. One to send, one to receive. But BiDi module send data on one wavelength, say 1310 nanometers, and receive on a different wavelength, 1550 nanometers, all through a single glass string. And that means our two-string fiber optic cable now give us two complete data paths. We use just one string for the active link and keep the other as a backup or for the future expansion. Speaking of which, this is our two-string fiber optic cable, and we're using pre-terminated single-mode fiber with LC connector. Pre-terminated is the key. It means it comes from the factory with the ends already polished, so it's truly plug and play, and we're running this 500 meters to the ranch. Now this one here is strength C. Let's use this one. Plug it into the SFP module. Just one string required. Then we can slide it into our media converter. That's a special design called the pulling eye on the connector. It's a mesh grip that takes the tension off the delicate glass fiber when we pull it through the conduit. Now, 500 meters later, the light arrives here at the ranch. This is where the signal gets reborn. That fiber cable is going to plug into another SFP module, but this time it goes into a special piece of gear. Our outdoor fiber PoE switch. Now see the SFP ports right there? We're going to plug the fibers in. Now we have 2 SFP slots, so I'm going to plug in 2 SFP transceivers. Even though we used only 1 cable string, we can use another one for backup, or you can connect to another piece of gear. Let's plug it into the SFP module. And instantly that light is converted back into an electrical network signal. But this switch does something the media converter at the RV couldn't do. It's PoE, Power over Ethernet. So out here, we don't want to run separate power cables to the cameras and Wi-Fi access point. So this switch injects power directly into the Ethernet cable. Just one cable run, give them both data and electricity. So it's clean, it's elegant, and it's far less likely to fail than having a bunch of extension cords. So without saying, let's plug in 2 Ethernet cable, one for the Wi-Fi access point and one for our pan tilt zoom camera. And we are going to plug in another Ethernet cable so we can send the signal here to our network video recorder so we can display video footage. Just give it a moment. Now everything is plugged in. Now you might be asking, how does this switch get power? So the owner has a small solar setup out there for a well pump. So we are tapping into that. But if you have AC power in the barn, you can plug it right in. The key is the fiber itself carries no power. It's just light, so the distance doesn't matter. Now we can see everything is plugged in, cameras are live. Now the ranch has Wi-Fi, it looks perfect. So it seems like our setup is done, but if we stop here, there's an invisible threat that could fry this whole system in a split second. That's lightning. Lightning doesn't have to hit your equipment directly. A strike 500 feet away can send a massive power surge. And when that surge hits, it will travel down the fastest way it can find. If we gave it a copper Ethernet line, it would blow a hole through every port on both ends. So fiber saves us because it's glass. It doesn't conduct electricity, but the media converter and the switch themselves are vulnerable. So we need to add the final layer of protection. That's the surge protector. The surge protector would divert that surge safely to the ground, so our equipment will be safe and sound. It's critical, so make sure you add a surge protector in an outdoor environment. So to recap, our Starlink signal left the RV as electricity, then turned into light a half kilometers and turned back into electricity, and our switch power a fully secure connected ranch. So we've turned a massive distance problem into a seamless high-speed network. Now running fiber isn't just for data centers anymore. It's the tool you need when the Wi-Fi gives up. Now if you're facing a long-distance networking challenge, feel free to drop a comment below, or you can check the links in the description for the gear we used. Thank you very much for joining us, and I'll see you in our next video.